We have this chemical equation which describes the decomposition of hydrogen peroxide. And we're told under these conditions it's a first order reaction. Now if you look through the rest of the information, we're given a rate constant, we're given an initial concentration of hydrogen peroxide, a final concentration of hydrogen peroxide, and we're asked how long will it take in hours? Well, this equation jumps to mind. This is the first order mathematical equation that relates concentration and time to each other. And we go, all right, let's see. Okay, we've got the final concentration. We plug that in, take the natural log of it. We have the initial concentration, plug that in, take the natural log of it. We have the rate constant. Well, plug that in. Don't forget about the minus sign. We have a unit issue because the rate constant units are per second, but we want hours. Okay, little issue there. And then we can mathematically rearrange it and solve for t, which is time. We can do that. That's fine. There's nothing wrong with this equation. But there's an easier way to do it. What do you notice about the final concentration with respect to the initial concentration? It's half, right? Now, if you don't notice that, you can use the mathematical equation I put down. Works fine. But if you notice that the final concentration is half of the initial concentration, recall that we did derive a simpler mathematical equation, which is this new equation on the bottom left. And there's not a whole lot to it. Take the natural log of 2, divide it by k, Bob's your uncle. Now we worked through a problem previously using the mathematical equation on the right. So I'm going to do this one using the simplified half-life mathematical equation. Let's plug stuff in. All right, first it's natural log of 2 divided by k, and I'm only showing it this way to clearly separate out the units. There's nothing wrong with putting 1.8 times 10 to the minus 5 per second in the denominator right underneath natural log of 2. It's fine. This helps me see my units though. Natural log of 2 doesn't have any units. We have seconds, but we want hours. So watch your seconds to hours conversion. And we get two significant figures because of the rate constant. So we get 11 hours. Now the danger in jumping right to the half-life mathematical equation for a first order process is, well, the big one is, do you remember it? But I think the bigger mistake is thinking that you can use this simplified formula for any concentrations, and you can't. It only works for half-life. So if you're not sure, go with the original formula I had up.